solid shapes, okay? So we're going to be talking today not about volume and surface area, but just the basics of them. What are these shapes? What are their names? What are their vertices? You guys need notes. What are their vertices? What are their cross sections? What's a net? A lot of words you may have heard before, things you may not have, and whether or not you remember them or not. Okay, I think these got stapled crazy. Actually, they didn't get stapled crazy. They got stapled fine. The stapler just wasn't working on the copier very well. So some pages are stapled, but the top page isn't. So bear with me. Take the whole stack and pass it back because they're not stapled like they should be. So take the whole stack and just pass it straight back. And I'll make sure that you're getting the whole group of notes. And like this one, it's the middle page that didn't get stapled well. So they're just kind of weird. Are you guys good? Make sure you're taking the whole stack and passing it straight back. Otherwise, we're going to get all confused. Are we good? Okay, I'm worried that we have it right back there, but okay. Everybody has one now except Kristen? Okay, make sure you have 3 sheets to your notes. If you don't, let me know and I can try to figure out what you need. Everybody needs 3 sheets, so make sure you're getting this whole stack straight back. I know, this one, none of them got stapled either. This one, it's stapled just 1 page, which doesn't even need a staple. If it's just 1 page. Oops, that's not right. This is top page, sorry. My bad. I'm going to mess things up. Remember, whole stack straight back. I'm slow here, sorry. All right. So make sure seriously that you have all 3 pages. Anybody not have a set of 3 pages of notes? It's out, Staples. Okay. You need another one? Okay. Here's another one. Do what? I don't know. So that there's not this long line waiting on one stapler every day to turn their homework in and. Yes. And then when things like this happen, it's easier. Okay, here we go. So basically, today's lesson, you're going to be asked to do just a few things. You're going to be asked to classify what shape do you have. So you're going to have to know the names of all of these different shapes and be able to write them out correctly. You're going to be asked to draw a net and be able to look at a net and decide what shape does that fold into. And just to kind of help you understand what I mean by a net, and we'll get to the vocabulary, but a net is basically the 2-dimensional shape before you fold it into its 3-dimensional shape. Okay, so you're going to be given pictures of 2-dimensional shapes like this and asked what shape would this be if you were to fold it together. Okay, so this, when it folds together, would end up being a pentagonal prism. And so that's the name of it that you're going to have to be able to know. You're also going to be asked about cross sections. You're going to be asked if you were to take this shape and slice it parallel to the base, what would the shape look like if you opened it up? Or if you were to slice it perpendicular to the base and opened it up, what would the shape look like? So we're going to talk a little bit more about that as well. So again, if you need to get your hands on a shape because you're having trouble seeing it, you're more than welcome to grab them at any time. I have a lot of nets, have a lot of 3-dimensional shapes, solids, and then cross sections you're just going to have to try to visualize unless you have Play-Doh at home. If you have Play-Doh at home, a great idea if you're struggling with what does it look like is create yourself a shape out of Play-Doh and then either take some dental floss or a knife and cut it like it's asking you to, and then you can really look at it and see it, okay? So just some ideas if you get stuck. Vocab. This chapter we will have a vocab test. There are a lot of vocabulary words in chapter 11, so we will go back to a vocab test, but we're also going to have a formula test, and it's going to be on the same day. There are less formulas for this chapter that you have to memorize, but you're still going to need all of them from chapter 10. I'm not going to re-quiz you on the ones from chapter 10. You're going to have to know them, but you're going to learn a few more formulas in this chapter. So the way that's going to look when we take it is one side of the paper is going to be vocab, matching, just like we've done all year long. The back side of it will be fill in the blank with your formulas. There'll be less, but you will have some formulas to memorize, okay? But obviously a lot of vocab here in day one. So we'll start with our vocab. First of all, three-dimensional figures are called solids. So when they say solids, they're just talking about those three-dimensional shapes. They can be made up of flat or curved surfaces. So the last section will be devoted to this shape, which is a sphere. Okay, so we'll talk about spheres all by themselves. Later, section 1 will talk about spheres too, but section 4 is the one that focuses on volume and surface area of a sphere. This one's easy to drop and have roll off your desk, so try to be real careful with that. On each shape, you are going to have to be able to figure out what is the face. What do we call a face? Each flat surface is called a face. Each flat surface. So does a sphere have a face? No. How many faces would this shape have? 6. It's got one on the bottom, one on the top, and then 4 around, right? So these are called faces. Each flat shape is a face. What's the shape of the top and the bottom face? A square. What are the shapes going this way? Rectangles. Okay, so what we're going to talk about is surface area, which is the area of every one of your faces all added together. So if you were to paint this shape on the outside, that would be the surface area. And then we're going to talk about what's called lateral area. The lateral area is the area of just the lateral faces. And the difference between a lateral face and a base is the bases are going to be the two shapes that are parallel to each other that have the same shape. So if you look at this shape, there are 4 rectangles and 2 squares, right? So the 2 squares are going to be the bases. The 4 rectangles are going to be the lateral faces. Are you guys with me? So base versus lateral face. They're all faces, but the top and bottom are the base. And be careful, because when I turn it like this all the time, that's when my students get confused. They want to say the base is a rectangle because it's on the bottom. Base does not mean bottom. Base is going to mean the 2 parallel shapes that are congruent to each other. In this case, there are 4 rectangles and only 2 squares, so it doesn't matter how I turn it. The 2 squares are the 2 bases. Is that clear? For example, look at this shape. What are the bases going to be? Triangles. There's 2 parallel triangles. There are 3, what shapes? Rectangles, and they are not parallel to each other. There's not a rectangle that's parallel to this bottom rectangle, right? So be careful, because when it's sitting like this, every year I have students who get so confused. They think, well, it's a rectangular bottom. It's not a rectangular base. The base is the 2 shapes that are parallel to each other and congruent. So it's a triangular base with rectangular lateral faces. Does that make sense for real? Okay, I hope you guys don't do it when it comes to the test. Okay, so face, then you need to know what is an edge. An edge is the segment that intersects 2 faces. It's where 2 faces come together. So top face, right face, where those come together make an edge. Right face, back face, where those 2 come together make an edge. So an edge is just a segment on your shape. So if we go back to the one I started with a few minutes ago here, which is similar to what we have up here on the board, how many edges will this shape have? How many edges will this shape have? 12. It's going to have 4 edges on the top, which means it's going to have 4 edges on the bottom, right? That's 8. And then it's got 1, 2, 3, 4 vertically. So that's going to give us a total of 12. Same with this shape that's on the board. Does that make sense? Questions? Okay. Vertex or vertices plural are going to be the points where those edges intersect. So if we look at our shape, how many vertices will this shape or this shape have? 8. It's going to have 4 on the top, but then it's also going to have 4 on the bottom. So 8 vertices, 12 edges, and 6 faces. Are we all good with what is a face, vertex, and an edge? Okay. Real quick, let's see if we are. How many vertices does this shape have? 1. How many edges does it have? 0. This is circular, right? An edge has to be a segment. There's not a line segment on this shape. It is all curved here, and it is all circular on the bottom. So there's 1 vertex, no edges. What about faces? It's got 1 face. It's the bottom flat surface, and that is a circle for a face. Okay, and what do we call this shape? A cone. Right. Yes. To get an ice cream cone, yes, we should totally do that. And then we could find the volume that is inside our cone. We just want to eat the volume. Yeah. All right. Vocab. Here we go. Prisms. Prisms and cylinders. We're going to group those together as we learn. So in section 11.2, we're going to focus on just the prisms and cylinders. And then pyramids and cones we're going to group together in section 11.3. The reason we'll group the prisms and the cylinders is because they are both shapes that have 2 parallel bases. The only difference between a prism and a cylinder is what is true about the bases on a cylinder. They're circular. Whereas on a prism, they're going to be things like triangles, squares, rectangles, trapezoids, hexagons, octagons. They're going to be polygons versus in a cylinder, you're going to have circular bases. But the formulas we'll be able to use will be the same for both of them. So a prism, by definition, is going to have 2 parallel, congruent, polygonal faces, which we're going to call the bases. And I just spent a few minutes trying to show you that. Emphasize that again. When you're looking at your shape, it doesn't matter how it's turned. Base does not mean bottom. Base means the 2 shapes that are parallel and congruent. So again, if I were taking notes, I would put base is not the bottom. It might be the bottom, but it is not, definition is not the bottom. Base means the 2 parallel congruent shapes. Okay? And they're connected by faces. Those faces are always going to be parallelograms. What did we say they were when we were looking at them? We didn't say parallelogram for the faces. What did we say? What did we call these shapes? Here. Rectangles, right? Parallelograms, would you agree that rectangles are parallelograms? Okay, they're going to call them parallelograms because sometimes these shapes are going to be slanted, and we're going to look at some shapes where they're slanted. If they're slanted, then they're going to be parallelograms. If they are bases are perpendicular to each other, where this red string shows that center to center is perpendicular, then they're going to be rectangles. But if this happens to be shifted, and I don't have any where they're slanted, but if any of these happen to be shifted so that they're slanted, they'll be parallelograms. Okay? Cylinder, same thing. It's going to be formed by 2 parallel congruent circular bases and then the curved surface that connects them. Pyramids and cones, what are they going to come to? What's going to happen here? They're going to have 2 parallel bases? No. You're going to take the sides around this base and they're going to come to a point or a vertex. So when you have cylinders and cones and pyramids, they're going to come to a point each time. So the pyramid does not have a circular base, the cone does. Everything else about them is very similar. These are going to get a lot harder because they're going to have two different kinds of heights, and I need your attention right now, paying close attention. This will be the hardest part of Chapter 11, are the cones and the pyramids, which is next Wednesday, and the reason being is because they have two different kinds of heights. So I'm showing you today the two different kinds of heights. This red string represents the original H height. Height means perpendicular to your base. So when you see that letter H, you're going to think height is perpendicular to the base. Are we good about H height? Okay, we're talking about the height of the cone, the height of the pyramid. Then there's going to be what's called a slant height. And they don't use the letter S, which would make sense, S for slant. They use the letter L because some books call it the lateral height instead of the slant height. It's the same thing. You can call it lateral height or slant height. And the slant height is going to be the height of the face. Or in the cone, it's the height on this curved surface. So notice my red string slides over. That's going to be your L slant height or lateral height. Let me get one where you can actually see it better over here. Look at the pyramid. Again, what are we going to call this red string right now? This red string right now. Regular height H. H height. Normal height. But if I slide it over, this is what we call the slant height or lateral height. And notice that it is just the height of one of your faces. Are you guys with me? So when you have to find this slant height in the third section, you're going to be finding it by finding the height of just one of your triangular faces. Versus the H height, which is going to go from the vertex perpendicular to your base. Okay, and I'll come back over and revisit that later, but I feel like if I show you a little bit today, it's going to make a little more sense later. Okay, so pyramids and cones, vocabulary. Pyramid is formed by polygonal bases. There's only going to be one base. It could be a triangle, hexagon, octagon, whatever. But all of the faces will be triangles. So here's a big difference. Prisms have parallelogram lateral faces. They could be rectangles or parallelograms. Pyramids have triangular lateral faces. Their bases can be anything. You'll see it really well in a net. Yeah. Okay, do you see these two nets? One of them is going to make a prism. One of them is going to make a pyramid. When you look at the faces, you'll see which one's going to be the prism and the pyramid. The prism has to be made up of parallelograms or rectangles, and the pyramid has to have a bunch of triangles. Which one has a bunch of triangles? The green one. It's going to fold up and make a pyramid. The base is going to be the one on the bottom or the one that may not be a triangle, which is obviously this shape. And what's this shape? Hexagon. So this is a hexagonal pyramid. This one has a bunch of rectangles. So it's going to make a prism. When we fold it up, the two shapes that are parallel and congruent are the bases. So when we fold it up, we get a prism. And this shape is the type of prism. What kind of shape do we have here? Pentagon. So this is a pentagonal prism. Triangular pyramid. So if I have a triangular pyramid, which would be this, notice that they're all triangles. So that definitely tells me it's going to be a pyramid. And then when I fold it up, it's just the one that's on the bottom that is your base. They could be different. You could have all of these equilateral triangles like this one, or it may be that the one on the bottom is a different kind of triangle. Maybe it's a right triangle and the rest are isosceles triangles. So it just kind of depends. But you'll be able to tell because it'll be the one in the middle when you fold it up. Okay? You guys seeing how this is a pyramid versus a prism? Whereas a prism has to have, let's find a different one, rectangles. So what would this shape be? In green. It's a pyramid. What kind of pyramid would it be? Gotta have a shape. So it would be a square pyramid because the shape that's in the middle is a square. Okay? What is this going to be? A cylinder. It's made up of rectangles, but it's not a prism because the two parallel bases are going to be circular, which makes it a cylinder. Does everybody see the difference there? Okay, yes. All right. Cones, circular bases as well, come to a point. They have a curved surface. So there's our vocab there. Okay, moving on. Go a little faster. Cubes are special because cubes have all the same faces. What faces do cubes have? Squares. And how many squares are going to be in a cube? 6. The book calls it a cube, but if you want to be more precise, write this down. This is really a hexahedron. Hexahedron is really the technical name of a cube. A cube is also called a hexahedron. So a cube is a prism with 6 square faces, and then it tells you that other prisms and pyramids are named for the shapes of their bases. So when I tell you, they're going to ask you to classify, these are the names that you'll be using. So you're either going to tell me it's either a prism or a pyramid or a cylinder or a cone, and then you're going to name what kind of prism or pyramid it is by its 2 parallel bases. So make sure you're looking for the 2 bases that are parallel to each other. Triangular prism, rectangular prism, pentagonal prism, hexagonal prism. Some teachers say pentagonal and hexagonal. I can't say it that way. I grew up saying pentagonal and hexagonal. But pentagonal and hexagonal are what some people say. Okay? Are you all understanding how to name it based on the base? Be very, very careful, though. One more time. What is this shape going to be called? Triangular prism. It looks like it's rectangular because I have it sitting on a rectangle, but the 2 parallel bases are actually triangles. So it's a prism, rectangular lateral faces with 2 triangular bases. Okay, and then if it's circular, it's either a cylinder or a cone. All right, the other thing I want to point out in this picture is notice that some of them are slanted. We call these oblique. Write this word down. The book uses it, but it's not on your notes right here. Oblique. O-B-L-I-Q-U-E. Oblique. Oblique means that it's slanted. So when it's slanted like that, it's still going to be a pentagonal prism. It just means that now these faces are no longer rectangles, they're parallelograms. That's why the definition says it's made up of parallelograms. They could be rectangles, but they may just be parallelograms. Are we good with that? Okay. When it's oblique, your height could be outside your shape, just like it is in triangles where they're slanted and you look at the height outside the shape. Okay? All right. So we're going to go straight into some examples here. It says classify the figure. Remember that means to give it the most precise name. So when you look at this shape, what kind of shape do you think it is? Okay, so I've heard cube and hexahedron. Does anybody else, when they look at it, think that this shape is not the same as this shape? Okay, looks to me like it could be this is a rectangle and this is a square. If that's the case, we wouldn't call it a cube, we would call it a square prism, because the 2 shapes that are congruent and parallel would be the top and bottom squares, and then we would have 4 rectangles going around the middle. So it just depends. I'm going to take your best educated guess, because on this section they're not going to mark things like they should for you to know for 100%. So if you said cube here, I would give you credit. If you said square prism, I would give you credit. Okay? On the test, I'll be very clear. So it'll have things like this that would help you know that this is a square prism versus a cube because the other ones are not marked. Okay? Or I'll do something like this so you'll know that it's not a square on the front, so it has to be a square prism. Are we clear? Okay, but the book says that this is a cube, hexahedron or cube. Name the vertices. This is going to be the tedious part of the homework. You're going to have to list the vertices. Do not just write down a bunch of vertices without telling me that's what the vertices are. So write vertices and then list them. What are the vertices in this picture? All the letters. Every letter represents a vertex. When you name the vertices, you cannot just write them all side by side. That's how you name a shape. You've got to put parentheses between them. So A, B, C, D, E. That's what I meant. What did I say? I don't know. How about a comma between them? Sorry. A, B, C, D, E, F, G, H. Is that all of them? That's 8. So A, B, C, D, E, F, G, H separated by commas. Commas. Don't write them side by side without a comma, because that's how you're going to name your two-dimensional bases, is you're going to put all the letters side by side. So it's important. Okay, then it says name the edges. This is also going to be the tedious part. How many edges did we say this shape is going to have? 12. And so you're going to have to list 12 line segments and name them correctly. This goes back to chapter 1, naming line segments. So here we go. Let's start with the 4 on the top. What are the 4 on the top? A, B. Make sure you put a line segment above it, comma, B, C, line segment, comma, C, D, and A, D. So I would start kind of somewhere on your shape and make sure you get all of those. Now let's go to the bottom and let's name the bottom bases, or bottom edges, sorry. What are the bottom edges? EF, FG, GH, and EH. And again, when you name a line segment, does the order matter? EH or HE? Not at all. All right, and then what 4 are we missing? Okay, the 4 vertical that go around the lateral faces. So let's name those. I heard BF, CG, DH, and AE. So kind of tedious listing all of those out. Again, make sure you tell me that these are the edges. Don't just write all these things down and not tell me which ones are vertices, which ones are edges. And then lastly, we're going to list our bases. Now here's the part that's important. If this is really a cube, any 2 squares could be called the bases, right? The top and bottom here could be 2 bases, or I could turn it, and now these 2 are the 2 bases, or I could turn it, now these 2 are the 2 bases, right? Because it's a square, it's a cube. All of these are squares, so all of them, 2 opposite sides, could be considered your bases. That's different from this. You only have 2 options that are your bases. 1 option that represents your 2 bases. What are your 2 base shapes? The triangles. So you have to list this triangle and this triangle are my bases. If it's a cube, you could pick any 2 opposite bases and name those. Does that make sense? Be careful with the one shape I mentioned earlier, because every year this becomes a problem. There's only 1 option for 2 bases here. When it's laying like this, I get a lot of wrong answers. What are my 2 base shapes here? The squares. You're naming the 2 squares as your bases. Okay? So in our picture, you're just going to pick 2 if you're calling it a cube. If you said it was a square pyramid, or square prism, then you're going to name the top and the bottom. So it doesn't matter, but pick 2. Pick 2. When you name your shapes, you're putting your letters side by side. So A, B, C, D, and E, F, G, H. Okay, just how we named them back in chapter 1 when we were naming a rectangle, a shape of any kind. But just pick 2. That does not matter. You can name that top shape any way you want. Just go consecutive. You could have said C, D, A, B, and then came down here and said E, F, G, H. That will not matter. You're just naming the 2 squares. Okay. The only thing that does matter is you cannot say B, C, A, D, because that makes a Z, not a square. Questions? All right. I'm going to go a little faster from here. Next one. You guys go ahead, classify this, name the vertices and the edges. Go ahead and do the next two in your notes, you and your buddy. Do the next two in your notes. Check it real quick. So back on this one, what do we call this shape? Pentagonal pyramid. Remember, it's coming to a point. If it comes to a point, it's a pyramid. If it has two parallel bases, it's a prism. Be really careful because I accidentally say the wrong thing all the time. But when you write it down as an answer, it's got to be correct, okay? So pentagonal or pentagonal, depending on how you pronounce it. Pentagonal pyramid comes to a point. All right. Vertices. How many vertices did this have? 6. Every vertex letter, every letter represented a vertex in this picture. So you would just list those. The order that you list them would not matter. Just make sure that you have commas in between them. Edges. How many edges did this have? 10. All 5 around the base, and then all 5 going up slanted to the point F. When you name those, remember that you have to put line segments above them and separate each line segment with a comma. Okay, so there should have been 5 around the bottom, 5 slanted up. Every line segment becomes an edge. Are we good? Okay. And then bases. How many bases does this one have? 1. Every cone and every pyramid has only 1 base. When you name that base, the order doesn't matter as long as you go consecutively one direction. Pick a place to start and then go consecutively in a circle. I'm alphabetical. It drives me crazy not to be, but you can do it however you want. So I would start at A and say A, B, C, D, E. There is not a line segment above this. It's not a line segment. It is the shape. No commas in it either. Questions here? Okay, what's the next one? It's a cone. Be careful on the cone. How many vertices does the cone have? Only 1. This point M is not a vertex. Point M is the center of the circular base. So be careful. The only vertex is the point at the top, N. How many edges does it have? None. There are no edges. Edges have to be line segments. When you feel the cone and actually look at it, this is all curved. There are no straight edges. This is all curved as well, so there are no straight edges. There are no edges on a cone. Same thing goes for a cylinder. There are no edges on a cylinder. It's all curved around the top, it's curved around the middle, and it is curved around the bottom. So there are no edges on a cylinder. Edges have to be where 2 faces meet. And so where those 2 polygonal faces meet, that sharp line segment is an edge. All right, so you can just put none. Or in A or whatever you want to write there. And then when you name the base, I saw a lot of wrong answers. A lot of people, when they named their base, just put M. That would be how you name a vertex. That's a point. When you name the base as a circle, remember we mentioned this last class period. You're supposed to have a circle with a dot in the middle. Not last class period, but last chapter. A circle with a dot in the middle. We barely briefly talked about it. Not a lot. But we'll talk a lot about it in the next chapter 12. So circle with a dot, and then you name it with the center. Are we good with that? Okay. All right, so nets. I kind of talked about nets already. Nets are your 2-dimensional shape that you get when you unfold your solid. So it's a diagram of the 3-dimensional figure that can be folded to make it. To identify your 3-dimensional figure, again, I would encourage you to look, do you have rectangles or parallelograms, or do you have triangles? That's going to help you decide, do you have a prism or cylinder, or do you have a pyramid or cone? Okay? Then once you decide which family you're in, the prism cylinders or the pyramid cones, then you can look to see what are my bases, the 2 pieces that would be parallel when folded together. Oops. So you're going to have to look at a net and describe what the shape is, and you're going to give me the name. So when you look at this shape, is it going to be prism cylinder or pyramid cone? Which family? Prism cylinder. Over in this family, it doesn't have triangular shape, so it's not going to be a pyramid or a cone. Prism cylinder, and then when you look at it, notice they are all what shapes? Squares. So what are we going to call something that's made up of all squares? Hexahedron or a cube. And you can write it either way. I'll accept either answer. But hexahedron is the actual technical name. Okay? So that's what they're asking you to do, is to take the net and decide, and I should have one of those. I don't have it laid out, I guess. But take that net and decide what it folds to. All right, look at this one. What is this one? So when you look at this shape, I don't see triangles or rectangles, right? Because they didn't draw them in. But now when you look at the shape, do you see it? Do you see the little triangles? They're not going to necessarily draw them in, but there are little triangles being formed here in this little section so that when you fold it up, it's going to make a cone. Okay? So if there's not any rectangles, you can be guaranteed it's not a prism or a cylinder. It's got to have rectangles for that to happen. So no rectangles is going to lead us to the pyramids or the cones. And if there's not any actual triangles, that's going to mean it's going to be a cone. Okay? Some things important about the cone for the next couple sections. Notice that when I fold this up, this distance around this curved section becomes what about the base? Circumference. Do you see how that matches to the circumference of the base? This distance around here lands right on top of the outer edge of the circle, which is the circumference of the base. So this piece right here is the circumference of the base. And then when you look at this shape, when it's all folded together, what did we say this height was going to be called? The one that's on this side. Slant height or lateral height. I call it the slant height because it's slanted and that kind of helps you, but some books call it lateral height. Slant height or lateral height. Notice that that height is actually the length from the center to the edge on this little curved section. So when I look at this picture, the distance from here to here is going to equal our slant height. And again, they're going to use a letter L for that, for lateral height or slant height. So from the center to here, when I fold it up, that is your slant height. Do you guys see that? Okay, we're going to come back to that in a couple days. All right, what do we have here? It has to be a pyramid because we have all these triangles, and then the one in the middle is the base, and so that's going to be a triangular pyramid. So make sure you're writing these answers down to help you on your homework. So we had cone, and then we had triangular pyramid. What's the last one in your notes? Which is what solid? A cylinder. Okay? Notice the big long rectangle. That rectangle is going to tell us it's in the prism or cylinder family, but when we fold it up, it's the two circles that are parallel bases. So this is a cylinder. Okay, last thing for today is cross sections. Any questions about this though, nets? You're going to have to be able to draw nets too. They're going to give you a shape and say, draw the net. Listen, if you have trouble on the homework, look through your book. There'll be pictures in there of nets, or Google. What does the net of a cone look like? What does the net of a triangular pyramid look like? And then get a visual until you get good at it, and then you'll be ready by the time you take the test, okay? In just a minute, I'll let you play with all of you want to, okay? Cross-section. Last subject. Cross-section, like I said, if you get stuck at home and you have any kind of Play-Doh, take some Play-Doh, make your shape, and then cut your shape. A cross-section is the intersection of a three-dimensional figure and a plane. So what that means, I think of my plane as like a knife. Or if you use dental floss, your floss is going to slice it like a knife, okay? So your plane is like a knife, and your three-dimensional figure is whatever you're dealing with. So if I take this three-dimensional figure and I were to take a knife and slice my three-dimensional figure so that it's parallel to the base, I slice it horizontally here. If I open it up and look at it, it should look just like the base does. So what shape would that two-dimensional figure be if I open it up and look at it? A square. Think about an orange. When you take an orange and you cut it in half and open the orange up and look at it, what two-dimensional shape do you see when you've sliced your orange in half? The sphere is the three-dimensional shape. What do you see as the two-dimensional shape? A circle. The cross section is the two-dimensional, should be a two, the two-dimensional shape. So when they ask you to name the cross section, you're giving me a two-dimensional shape. Okay, so take this triangular prism. If I slice it parallel to the base, what should the two-dimensional shape be when I open it up and look at it? A triangle. It should be the same as my base. Now be careful. If I slice it perpendicular to the base, so now I'm going to cut my shape like this. And this is where sometimes getting a Sharpie or an Expo marker and drawing it. So if I cut it here, and then cut it here, and then cut it here, and then cut it back up here. What shape is that going to be when I open this up and look at it? Rectangle. 1, 2, 3, 4 sides makes it a quadrilateral. And then obviously when I look at that, I can see that that's going to be a rectangle. So if you need to, draw it on your shape and look at it. If you need to, get an actual thing of Play-Doh and cut it. But you're going to have to come up with the two-dimensional shape. We're going to use the phrases when we're describing it. These are the key phrases you're going to want to use on your homework and your notes. Parallel to the base or perpendicular to the base. That's perpendicular to the base. Now you can slice it other ways. You may slice it diagonally, but typically on the homework and on the test, those are going to be the key ways they're going to talk about it. If you slice it parallel to the base, what does the shape look like? If you slice it perpendicular to the base, what does the shape look like? And they'll say it that way versus horizontally and vertically, because if my shape's sitting like this, and I say horizontally, that could be different than if it's like this and I say horizontally. So we want to describe it in reference to the base. Parallel to the base results in a triangle. Perpendicular to the base results in a rectangle. All right, let's see how you do. So, when you look at this cross section, it's basically like taking your knife and setting it on top of your cone. Where do they intersect? At the vertex. So what is the actual geometrical shape where they touch? A point. Sometimes your cross sections are just a point. It's just the tip of that cone, so it's just a point. Okay, so the cross section is a shape. You're just naming the shape. In this case, it's a point. What is the two-dimensional shape here that is our cross section? Pentagon. Notice 1, 2, 3, 4, 5 sides. So your answer would be pentagon. A cross section is just the shape where they touch. When you've sliced it, what is that shape that you see? Okay, what would be my cross section here? Hexagon. And the book does beautiful in the picture, so if you're getting stuck, look back in your book in the section, because they draw them like this, so it's really easy to see. All right, what about this one? Triangle, and it would be isosceles. You don't have to be that specific, but yes, it would be an isosceles triangle. How would you describe that cut? Parallel to the base or perpendicular to the base? Perpendicular to the base. What would you get if you had sliced it parallel to the base? A circle. All right. Okay, so this one gives you some pictures, right? Mine's missing. So read the directions here and see if you can answer the next two problems. The next two. We're not going to do the last one at the very bottom. So try the next two and then we'll be done. There are. They grow in Japan. They're easy to ship because and then that way they fit in a box really easily and they can ship it. Yeah. No, for real. No April Fools. This should be a description. It says, how should you slice it? So think about your key phrases. Parallel to the base, perpendicular to the base. How should you slice them? Make sure you've answered both questions, Corbin. I'll show you, but we're not going to actually do it. Okay, let's see how you're doing. A piece of cheese is a prism with equilateral triangular bases. You may have some problems where they don't give you a picture and you have to come up with the picture. You're going to have to draw three-dimensional solids as we go throughout this chapter. You may need to practice that. Again, look in your book, trace if you need to until you get good at it. But a piece of cheese is a prism with equilateral triangular bases. So that means it's got equilateral triangles that are being connected, and I know they gave you a picture, but eventually you're going to have to draw one, that are being connected by these rectangular faces, okay? So you have this piece, and it says, how can you slice it so that you make an equilateral triangle? Would you slice it parallel to the base or perpendicular to the base? Parallel. You want the same shape as the base, so you want it to be parallel to the base, which means you're going to slice it like this. So when you slice it, you're going to get that same little shape here in the middle. Okay? And of course, they do a much better job at the picture than what I did. So it should be parallel to the base. So you can see that parallel to the base gives us the same shape as the base. If we look at the next one, we want to get a rectangle. It's the same shape. So how are we going to get a rectangle? Parallel to the base or perpendicular to the base? If it's parallel to the base, you're going to get the same shape as the base. What's the shape of the base? Triangle. So it can't be parallel to the base or it'll give you a triangle. It's got to be perpendicular to the base. Do you see how that is? So if you cut it perpendicular to the base, that means you're going through your two bases. You're going to result in this rectangular shape. All right, last one. We're not going to really do, but this one's really hard. It says, how can you slice this to get triangles? And so you would have to slice it so that you're going from the center of two consecutive edges and then to the third consecutive edge that meet at a common vertex, so that when you slice through that, you would end up with a triangular piece. Do you guys see that? Describing that takes a lot of work. You'd have to talk about the center of three consecutive edges all meeting at the common vertex to slice it to get your triangle. You won't have any that hard. Okay. You have about 15, 16 minutes or so. Get started. You're welcome to come get any shape you want and play around with that. Homework is due Monday.